All right, so picking up from where we left off yesterday, we were talking about the key characteristics of linear functions. And today we're going to be focusing on a few more. We've got about 6 more that we're going to look at today. So the one we're going to focus on today is called the interval of positive. The interval of positive. Now, the interval of positive is the interval of the points on a line that are above the x-axis. And the key words here are above the x-axis. Okay? That's the key here. We were looking for where it is above the x-axis. So what I like to do here is I like to kind of divide it up. I like to start here at my x-axis, and I just like to kind of maybe use a different color, or in this case, use like a zigzag line just to indicate where above and below is. So if I look at where I just drew that zigzag line, everything that is above or higher than that line, that's going to be above the x-axis. Anything that is below, okay, going down is going to be below, is going to be underneath or lower than the x-axis. So in this case, we're looking for above. So when we look at above, above is what we're looking at because it says above. So interval of positive is when we're above the x-axis. Now, if we look at this, the only area where our line is above the x-axis is starting at this point and continuing upward, right? That's where our values are going to be above the line. So what we have to do here in order to write the interval of positive is we're going to look at the x values and determine where these lines are going. So starting here at this point, we know this point is located at what number? -2. So it's going to start at -2, and we're going to start at -2, and we're going to continue to grow up, but we're also going to continue to go to the right. So we're looking at when it's above. So from here on out, everything's going to be above the line. It's not going to go back down below the x-axis. In other words, it's not going to cross this line here. It's going to stay above. So since this is going to stay above, we want to be able to determine for how long will it be above. So is it going to be above at -1? Yes. Is it going to be above at 0? Yes. Is it going to be above at 1? Yes. Eventually, it's going to continue to go up, right? So if we continue with this, will it be above at 2, 3, 4, 5, and then continue on forever? Will it always be above from here to the right? Yes. So it's going to be basically above from -2 all the way until we reach infinity. So from -2 to infinity is going to be when the line is above the x-axis. Now, when we write this, we have to understand that this point exactly on there is equal to the x-axis. So can something be above the x-axis if it's equal to the x-axis? No. So what we do here is instead of putting a bracket, because that point is on the line to indicate that it can be equal to, we want it to be everything above or greater than that line. So here we're just going to indicate that we're going to put a parentheses around -2 and a parentheses around infinity to get our answer. So like I said, our answer for this one is going to be the interval of positive, which is -2, parentheses, or comma, infinity with bracket or parentheses around it. Now, let's look at another example just to make sure we've got this. So let's say we were to look at an example like this, where we had maybe a line that was increasing as well. And we'll say that it has 2 endpoints, with the endpoints here starting at, let's say this starts at -5, and then this one ends at 4. And it crosses this y-intercept here at -1. So when we look at this, or the x-intercept at -1. So when we look at this, what we're looking at our information here is we're looking for everything that is above the x-axis. So is this part, when we look at this part down here, is this going to be above the x-axis? All of this here? No. None of this is above the x-axis. All of this is actually below the x-axis. So we're not going to worry about that right now. But when we get to this point, and this point's located at what x value? -1. So it's going to start here at -1, and then is it going to be above after -1? Is it? Is this above? Yes. So everything after negative 1 is going to be above until it reaches the end point, which is going to be located at what number? 4. So here what we're looking at is we're looking at everything being above the x-axis from negative 1 to positive 4. So that's going to be from negative 1 to positive 4. Now to determine if it needs brackets or parentheses, we know that it cannot be above if it's equal to here because it's on the line. So negative 1 is going to get a parentheses. And then for 4, 4 is above when it's equal to, so we can say that's equal to. So we're going to put a bracket around 4. And then that would give us our answer for this one. So that's just a couple of examples that you can look at here to identify the interval of positive. What we're looking at is when it is above the x-axis. So what interval or what x values is our line going to be above the x-axis? If you have any questions, go ahead and pause it. You can stop for a second and then raise your hand and I'll answer any questions that you have. All right, so if nobody has any questions on this, what we'll do is we'll actually go to our next slide and we'll talk about interval of negative. Let me clear the ink off here. So with the interval of negative is very similar to this. With the interval of negative, we're looking for the interval of the points. So the interval of the points on a line that are below the x-axis. So here the key word is below the x-axis. So once again, on our graph here, we're going to look at the x-axis, and I'm just going to make it, like I said, you can do it a different color if you want to, if it helps you see it a little bit better. I'm just doing a zigzag line. And then what I want to do is I want to look for everything below. So if you recall, I said that everything below is going to go down. This is going to be below. So if I look, everything that's below is going to start, well, it's going to start way down there, right? And it's going to come up all the way until it gets to here, which is at negative 2. Then we get into our interval of positive, which is from negative 2 all the way to infinity in that direction. So with that being said, if this continues to go down and to the left, what is the furthest to the left we can go? Negative infinity. So the furthest we can go to the left is negative infinity, and then the furthest this can continue to go up until it crosses the x-axis is to negative 2. So in this one, everything's going to be underneath, starting at negative infinity, and it's going to come up, 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 until it gets all the way up here to negative 2. And then at negative 2, it changes from being negative to positive. So when we look at this, the interval of negative here is going to start at negative infinity, and it's going to be negative until it gets all the way up here to this number, which is at negative 2. Now, once again, we already know that anytime we have an infinity, it always gets a parentheses. But here we cannot put a bracket around this because if we include negative 2, that means that it is equal to the x-axis. And we're saying that the x-axis is below. We can't say that. The x-axis is kind of like in a neutral zone here. So what we do is we say that that negative 2 is not included and put a parentheses around it to indicate that. So with interval of negative, we're looking for the values that are below. A second example of that, let's take another example. Let's say we had something, let's actually look at one that does this time. In other words, it decreases. So in this one, we got negative 3, let's go to positive 4, and then let's say it crosses right here at positive 1. So if we wanted to find the interval of negative, we're looking for everything from where it crosses the x-axis and then goes down. So here, everything that goes down to this point. So that's the area that we're looking for, everything below the x-axis, everything underneath this x-axis, okay? So if we look at everything underneath that x-axis, it's going to start here at 1, and it's going to go down all the way until it reaches this point, which is located at 4. Now, in this one, we know that we're on the x-axis here, so that cannot be equal to, so that's going to be parentheses. And then the 4, we know that 4 is going to have an equal sign, or going to have a bracket because of the solid dot. Therefore, it gets a bracket, and we have our answer for our interval of decrease. If we wanted to find the interval of increase in this one, we would start up here at negative 3, and then negative 3 would approach 1, so the interval of increase, so that you don't get confused, would be from negative 3. So it'd start here at negative 3, and it would go all the way over here to 1, and 1, would give us our value. So that would be bracket and parentheses. So we can identify interval of increase or my bad, not increase, what am I thinking? Positive or interval of negative by simply identifying the different sections of the graph. So that'll come into play. We probably won't look at that a whole lot today, but you will need to know that for future reference, especially tomorrow. So make sure you know this. If you have any questions about it, we can talk about it. But like I said, know how to deal with interval of positive and negative, and know how to get your answer when you're dealing with those. All right, if you have any questions, pause the video, and then we'll talk about our next two really fast. All right, so talking about the next one, we're going to get into the maximum. The maximum is going to be the highest possible point. Okay, the highest possible point in a relation to the y-axis. So if you think about this graph, it's easy to see these because where's this graph headed? If I look at this graph, it's going up, 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 up. Does it stop going up? Nope, it keeps going up. So if this continues to go up, where's it going up to? Infinity. Eventually it's going to reach a point at infinity. Now the thing is, we can't say that the highest point possible is infinity because the highest point possible, infinity is not a point. Okay? Infinity just means that it continues to grow with never stopping. So if something never stops getting higher, can it have a stopping point that's a maximum? No. So what we do here is we say that the maximum for this particular problem is going to be no max. Now, like I said, that's only when it's approaching infinity. If it was another problem, say it was a problem like this, and you had endpoints, and let's say this was at 6, and then this was at -4. Okay, then we could say the maximum for that graph in this graph, the highest point that it's going to reach is going to be at 6. So the max for this one would be 6. So determining the max, it just needs to be able to look at it and tell. Does it have an endpoint? If so, then the max is going to be at a certain number. If it does not have an endpoint, it has an arrow, then it's going to be no max. Now, with minimum is very similar. That's why I didn't change anything. Minimum is the lowest possible point. So if this continues to go down, then eventually this is going to go all the way down to what? Negative infinity. So here the minimum would be approaching negative infinity, but I know I can't reach a stopping point at negative infinity. So very similar to the maximum was no max, the minimum here is going to be no minimum. Over here in our other example, we can see that the minimum actually reaches a stopping point, and that stopping point is located at -4. So in this one, we could actually say that this has a definite minimum, and that minimum is located at -4. So with maximum and minimums, we're just looking for the highest point possible and the lowest point possible. If you have any questions about this, pause the video, and we'll talk about maximum and minimum. All right, so we're not going to spend a lot of time on rate of change because we're going to use a specific day for this, but really all you need to know for rate of change is rise over run. So in other words, if you start with 2 points, I like to use my x-intercept and my y-intercept. And basically, if you look at it, go up 1, 2, 3, 4, and then to the right 1, 2. That's going to be up 4, because it's positive 4. And then right 2, which is going to be positive 2, and 4 divided by 2 gives me a slope of 2. So identifying slope isn't hard. All I need to remember here is that with a straight line, it's going to be constant. All right, it's going to be a constant slope whenever it's a straight line. So that's the key here, key thing you got to remember. All right, so with that being said, the last one we're going to talk about is end behavior. Now, end behavior requires you to be able to write a specific phrase down. And that specific phrase is going to be as x approaches, and you can abbreviate approaches with an arrow, but as x approaches infinity, f of x approaches. And in this case, as we go to the right, or as x goes to the right, the values here are going to continue to go up as we go to the right. So here, this is slowly approaching infinity. So we can say that that's going to approach infinity. And then we also want to say as x approaches negative infinity, f of x approaches. So in this case, as we go to the left or towards negative infinity, we're going to go downward and approach negative infinity as well. So here, this would be negative infinity. So we're looking for where it goes on the ends. So if you had an example that had solid points, we would say that as we move to the right or towards infinity, this one's going to approach, let's say that's 3. So as we go to the right, it's going to approach the highest point, which is at 5. And as we move to the left, it's going to approach the lowest point, which would be at, in this case, let's say negative